Okay, in our last class, we had looked at the problem of drawing 5 cards from a 52 card deck. 5 cards from a 52 card deck. We're assuming the deck is shuffled, so it's random. And we want to look at the number of ways that we could draw 5 cards from a 52 card deck. So when we looked at that in the previous example, we looked at, these 5 cards are the ones that were going to be handed. It really wouldn't matter if these were dealt, if the dealer had handed around to every other player and went around 5 times or handed us 5 cards at once. If the deck is shuffled, the odds are going to be the same that we end up with a certain hand. And then we have the rest of the deck. Okay, so these are 47 cards. And here are the 5 cards. So in the previous example, we had come up with a formula for this where, let's see, we had that the permutations for this were 52 for 52 objects, taken 5 at a time, was 52 factorial over 47 factorial, which would be 52 minus 5 factorial, right? And we said, okay, we have the entire stack, so there are 52 ways, or 52 factorial, I'm sorry, ways to shuffle the deck. So that would be the whole deck, and that gives us our numerator. And then we said, but of those, we don't care about the order for the rest of the deck. Okay, so the order does not matter for this. And there were 47 factorial ways to order the remnant of the deck. Since those didn't matter, we wanted to divide the 52 factorial by the 47 factorial. But in most games that you play, we had pretended that the order of these 5 cards mattered. Maybe if you drew 1 card per turn and then had to make decisions based on that, it would matter. But in most games, you're handed all 5 cards at once, and they're usually face down, and then you pick them all up and you sort of sort them in your hand. So usually, we're going to now consider what happens if the order does not matter. Okay, so you pick up your cards and, maybe you have an ace of hearts, and then you have a 2 of diamonds, and then, we'll throw in some black cards here, and you have a jack of clubs, and you have a 4 of spades, and you have a 3 of clubs. All right. While you pick all of those up, you can take them in your hand and you can sort them any which way you want. So it wouldn't matter if the ace of hearts had been the first card or the 4th card, you have the same hand to play with. So for most games, it does not matter which order those cards were laid down. Okay, and since it doesn't matter, we treat it exactly like the rest of the deck where the order didn't matter. So if the order does not matter, we consider there are 5 factorial ways to order this. Okay, and if the order doesn't matter, then what we could say is the following. We want to find how many combinations of 5 cards can be drawn from a 52 card deck. And the key word here being combinations. When it's combinations of cards, we don't care about their order, right? What we were looking at before were permutations. And for permutations, it matters whether the ace of hearts is drawn first or third or last. For combinations, it just matters whether you have the ace of hearts or not. So once again, for combinations, you have to be working with something like a deck of cards where once a card is played, it can't come out again. But that defines the mathematics, but we can reorder the cards that we have. All right, so we're going to treat the 5 factorial just like we treated the 47 factorial. So the combination of 52 comma 5 would be equal to 52 factorial, all of the ways we can shuffle the deck, divided by 5 factorial 47 factorial. Okay, so the first part of this is the 5 cards that we did draw, but we're not worried about the order in which they came out. So we divide by the 5 factorial ways that could have happened. And the second pile here is the pile that we didn't use, and there were 47 factorial ways those could be sorted. So we take the total number of ways the deck could be sorted and divide by those 2 things to find the number of combinations. All right, so let me stop this video and we'll talk about computing those in the next video.